trig functions. So if you were fine with the polynomial transformations, they're exactly the same thing. And then we're going to move on to modeling with trig functions. So that's creating a trig function using a word problem. Okay. And after that, either before or after break, I'll give you guys some practice. You guys are actually going to do Kahoot and math in grade 12. So we will get to do that. My data management class actually liked the Kahoots. I don't know if they were just bored from being online that they needed the Kahoot. But nonetheless, it's fine to bring this into class from time to time. So have fun with it, okay? You don't have to put your real name, put a fake name, put a nickname. So yeah. So that we'll do either before or after the break, depending on how long this takes us. So we're going to be doing transformations with trig functions. Okay, so remember that in polynomial functions, we had it in the form of y is equal to af times k times x minus d plus c. So each parameter is associated with a specific transformation. So for example, we associated A with the vertical stretch or compression. So if A was negative, it was reflected in the x-axis. K was represented as the horizontal stretch or compression. D is the horizontal translation. And C is the vertical shift of up or down. Okay? So remember, this was from, I think, when did we do this? I think a couple days ago. So we said A is our amplitude. The equation of the axis is C, so it's going to be the last number in our equation. Our period is 2 pi divided by our k value. And if the independent variable has a coefficient greater than 1, then the argument must be factored to separate the values of k. So for example, if we have y is equal to 3 times cos of 2x plus pi, remember this is not factored yet, so we have to factor the 2 out. So we would rewrite it as y is equal to 3 times cos of 2 times x plus pi over 2. Okay? So stretches and compressions and reflections must be applied before any translations. So we can use the mapping notation with the transformations of trig functions. You can do the same thing. It's just instead of numbers, you're going to be using radians. Okay? A and C will affect the points of going up and down or side to side. And K and D will affect the x-coordinates of each point on the parent function as well as the domain. So strategies for sketching, honestly, just use the mapping notation. This is probably the easiest one. So remember, when you're using the mapping notation, you need to remember the parent trig functions. Which is y is equal to sine of x, and y is equal to cos of x. Okay? You need to remember the key points of these two functions so that you're able to use the mapping notation properly. Okay? So when plotting these, you're just going to be plotting one cycle unless it states in the question otherwise. So yeah, let's just get into some examples. So, for example, we want to state the period, the amplitude, the horizontal translation, the equation of the axis for each of the following examples. So, let's start with the easy thing first. What would our amplitude be in this equation?
1/2.
1/2, because that's our A value. Let's go with the other easy thing. What is our axis of symmetry?
Y is equal to 7.
Y is equal to 7. That's our last number. So remember, this is A and this is C. Do we have any horizontal translations? Look in the bracket.
A reflection in x-axis or y-axis.
We have a reflection in the y-axis. But what about our horizontal translation left or right?
Oh, yeah.
Mhm. Reflection on y-axis, and we have a horizontal translation of 3 pi over 4 units to the left. And what is the last thing we need to figure out?
Period.
Our period. So given from the first page, what is our period equal to?
2 pi over -1.
So 2 pi over the absolute value of k, which is equal to 2 pi over -1, which is just equal to what?
Yeah, because you have.
No, remember absolute value.
Oh, no, 2 pi.
So just 2 pi. So our period is just going to be 2 pi in this case. And then when graphing it, what would our mapping notation look like? What's our k value? So you have negative x. And then what was our horizontal translation?
3 pi over 4.
So because it's to the left, so minus 3 pi over 4. And how about our y's?
So 1 over 2y
Mhm.
plus 7.
Plus 7. Plus 7. And then you would use the points from our parent function sign, and you would just plug in the x and y values to get the new x and y values. Okay, let's go on to the next one. So the next one we have is y is equal to -5 cos times 4x minus 2. So what is the first thing we're going to have to do in this case? We're going to factor out the 4. So we get y is equal to -5 cos of 4 times x. And what do we get when we factor that out? Sorry, pi over 8. X minus pi over 8. Okay? And now all we have to do next is state our amplitude, axis, if there's any horizontal translations left or right, and our period. Okay? So what would our amplitude be?
-5 or 5.
Positive 5. What is our axis?
Y is equal to 0.
Mm-hmm. Do we have any reflections?
In the x-axis.
Yep. So we have a reflection on the x-axis. Any horizontal translations?
5 over 8 units to the right.
Mm-hmm. And last but not least, we need to figure out our period, which is 2 pi divided by the absolute value of k.
4.
What is our k value?
4.
4. So you get 2 pi over absolute value of 4, which when we simplify gives us what?
5 over 2.
Pi over 2. So as you can see, it's exactly the same idea as polynomial functions, except we're now using radians instead of the x values, like regular numbers. And A and C are just the amplitude and the axis of symmetry in this case. So in example 2, we're given the descriptions and the transformations, and we want to determine the equation of the resulting trig function. So the first one, our parent function is going to be sine x. So a vertical compression by 1/3 is issued, and then a reflection in the y-axis is also there, and a horizontal translation of pi over 6 units to the right is in this transformation function. So we're going to start as per usual. Y equals, what's the first thing we're going to write?
1/3.
So 1/3. Sine negative x, and then because we have it to the right, minus pi over 6 in the bracket. And is there any vertical shift up or down? No, so we just leave it as that. So our transform equation is going to look like y is equal to 1/3 times sine negative x minus pi over 6, and that would be it. Now the next one, we're focusing on cos x. This one looks a bit different. So we have no horizontal shifts, no reflections in either of the axes. Our period is 4 pi. Our amplitude is 6, and then the equation of the axis is y equals to 5. Okay? So we have our A, which is 6. We have our C, which is 5. What is the only thing that we have that's missing?
Okay.
Okay, yeah, we're missing K. So we know our period is equal to 2 pi over K. And what is our period in this case?
4 pi.
So 4 pi is equal to 2 pi over K. So now we want to isolate for K, so we're just going to cross multiply. So we get absolute value of K is equal to 2 pi over 4 pi, which is equal to what? 1/2. But because it's absolute value, it's either positive or negative 1/2. But can we take both in this case? Can there be a negative K? No. Right? Why is that?
Because
There's no reflection. So we ignore the minus, and it's just going to be plus. So you have our K is equal to 1/2. And now we can complete our equation. So we have y is equal to 6 cos of 1/2 x plus 5. So is this bad at all, these transformations? Basically a repetition of unit 2 with radians. Okay, now we need to come up with an equation for the graph. So we're going to be using the graph to come up with an equation. Okay, so there's a couple things we can determine just looking at the equation, or looking at the graph, or we can just use what we learned from before. So how do we usually find the amplitude of a graph? So what is the maximum y value in this graph? 1. What is the most minimum value of this graph? -5. So you have 1 minus -5 divided by 2, which is equal to
6/2.
6 over 2, which is equal to 3. So we have our A is equal to 3. So we have one part of the equation down. What is the next easiest thing to find? Okay. What's the last value of the graph? The equation, C.
I was thinking of that.
So C is equal to, nope, that would be our equation, right? So if amplitude is max minus min, what would our equation be?
The max plus.
Yep, max plus the min divided by 2. So you have 1 plus negative 5 divided by 2, which is equal to 1 minus 5 over 2, which is equal to negative 4 over 2. And what does that give us? Negative 2. So this is our equation of the axis. Y is equal to positive 2. And our amplitude is just how high the graph goes from the axis. So our amplitude is over here, and this is 3 units. And this is also 3 units as well. Now remember, how did I say you can spot a period on the graph?
Peak to peak.
Peak to peak, okay? So, or peak to peak, or trough to trough, or bottom to bottom, okay? So we have a peak here at what x value?
-7.
And another peak value at 1. So what would our period be from -7 to 1?
8.
8. Okay? We don't really need the period in our equation because that doesn't represent the k value. So what are we going to use to find the k value?
8 is equal to 2 pi over k.
So we have 8 is equal to 2 pi over k. Now we just cross multiply. We got k is equal to 2 pi over 8. And if we simplify that, what does that give us?
4.
Pi over 4. So that would be our k. So you have our A, which is equal to 3. C is equal to -2. And k is equal to pi over 4. Now we need to determine whether or not we want this to be a sine function or a cosine function. You can pick both. You want to pick cos? Okay. So if we pick cos in our parent function cos of x, does the graph start at the axis or at the maximum point? So cos starts at the max. Okay. So in this graph, where is the first max?
-7.
-7, or if you want it closer, at 1. Okay? So because cosine starts at the max, from the point 0, 0, which way is it shifted to get to the max? So technically just right, okay? So we are gonna move 1 unit to the right to start at the max, okay? So what would our horizontal translation be then? Now that we discussed it.
-1.
Yeah, so 1 unit to the right. Or it'll look like in the bracket as x minus 1, okay? Now, let's take a look at sine. So sine starts at the axis. Okay, and if we wanted this one to be a sine function, which way would we have to shift it so that it would start at the equation of the axis? Left by
2 units.
1.
Oh, 1.
Because it's over here. That's 1 and 2. So this would be a horizontal translation of 1 unit left, or in the bracket it would be x plus 1. So we have two possible equations to write using sine or cosine. On a test, if I just say determine a sinusoidal function, you can choose either or. Okay, just make sure the horizontal translations are correct when you're looking at the graph. But you can always use more than one, unless I say what is a sine graph for this graph or what is a cosine equation for this graph. You're free to choose whichever one you're most comfortable with. So if let's use our sine. So we'll have y is equal to 3 times sine. We have our k, which is pi over 4, times x plus 1 minus 2. Or if we wanted our cosine graph, we can write our cosine equation as well. Or it's the same thing, y is equal to 3 cos of pi over 4 times x minus 1 minus 2. So again, there's always two possibilities of which graph to okay. So does this sound very straightforward so far? Okay, and now we're going to get into some curve sketching. So we want to sketch the graph of each function for the given domain and state its range. So our first one is y is equal to negative, or y is equal to sine of negative 2x plus 3. So right off the bat, what would our equation of the axis be? 3. So that would be our equation of the axis for this equation. So axis y is equal to 3. What's our amplitude?
0.
Nope, not 0. It's 1. Our amplitude is 1. And now we have to figure out what our period is. So our period is equal to 2 pi over the absolute value of k, which is 2 pi over negative 2. And what's 2 pi divided by the absolute value of negative 2? Just pi. So our period is pi. So do we have any reflections?
Yeah.
Which axis?
Y.
Yep. So to determine the scale in which you're going to divide your x-axis into, this is known as a critical interval, okay? And all you're doing to find this critical interval or the scale of your x-axis is you're taking 1/4, multiplying it by your period. Okay? In this case, we have 1/4 times pi. So what would we divide the intervals, the x-axis in? What interval? What's 1/4 times pi? Power of 4. So you're going to be dividing each section into power of 4. So this would be power of 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so on. Okay? And that is how you would divide your x-axis into. Now what we will have to do next is graph this equation. Okay? Who remembers the key points for our sine function? Yep.
Yes. And 1. Or, yeah.
Yep. What is it? 3 pi over 2?
Pi over 2. Wait,
Pi over 2.
4 is the first one.
Pi over 2. What does the scale go by? 3 pi over 2 is next. Or no, pi is next. Sorry.
0.
Pi is 0. Then we have 3 pi over 2.
1. No, -1.
Negative 1. And then we have
0.
2 pi, which comes back to 0. Okay? So we're going to need to use this information to map out our new points. So we have xy turns into, and what would our mapping notation equations look like?
No.
So we have negative,
Okay. -2.
remember it's flipped. 1/2,
Oh,
right? And then what would our y values be?
y plus 3.
Y plus 3. So we have our first point, 0, 0. If we sub it into our mapping notation formulas, what would our first transformed point be?
0, 3.
0 and 3. All right. Our next one is pi over 2 and 0. So if we sub in pi over 2 for x, what would our new x value be? Yep, so we have -1/2 times pi over 2, which just gives us negative pi over 4. And what would our new y value be? Oh, what did I put 0? It's 1.
4.
4. Okay. And our next point we have is pi and 0. And if we transform that, what do we get?
Pi over 2
Mhm.
and 3.
Okay. And then we have our next one, which is 3 pi over 2 and 1, or -1. And what does that transform into?
-3 pi over 4 and 2.
And and 2, which is over here. And last but not least, we have 2 pi and 0. And what does that transform into?
Negative 2 pi over 2, or negative pi.
Negative pi and 3. Okay? So, but what is our restriction?
Be greater than 0.
But less than pi, right? So we can use the points we took in the negative x-axis and just apply them to the positive x-axis, okay? So our graph on the left side is going to look like this. So what would our next points be based off the pattern that we are getting? So at pi over 4 would be 2. I mean, at pi over 4 would be 2. What would pi over 2? What would the y value be? And we're just creating a wave. So at 2 pi over 4, it would be 3. Then would it go back to 4 and then come back down to 3? So the reason why this first half gave us these points was because of what characteristic of the equation? The negative, right? Because it was reflected in the y-axis, so that's why it was going to give us the points in the negative x-axis, okay? But you can still use those points to plot out the rest of the graph because your highest point is either going to be 4 and your lowest point is going to be 2, okay? So, and if you continue the pattern of pi over 4, as you can see from left to right, it hits a top at the negative pi over 4, and then it reaches the axis at 0, which means it has to go back down to its minimum, okay, and then continue that same pattern. So this one has a bit more transformations, but we can probably graph it perfectly fine. So this one's going to be easy. The reason why is because we don't have a reflection in the y-axis. So it's going to give us all the points on the positive x-axis. So our equation is y is equal to negative cos of 3 times x minus pi over 3 plus 1. So let's start with our basic things first. What is our equation of the axis, or our c value?
Equal to 1.
So 1. So y is equal to 1. What is our amplitude?
1.
Amplitude is equal to 1, which means based off the axis, what would be our highest possible point and what's going to be our lowest possible point?
2.
Yeah, so our maximum is going to be 2, and our minimum is going to be 0. Okay. And now we need to figure out our period, which is equal to 2 pi over k, which is equal to 2 pi divided by 3, which is just 2 pi over 3. Okay, and that is going to be our period. Now to find that critical interval, what do we need to do to determine how to divide our x-axis up into?
Order times period.
Mm-hmm. So our critical interval is going to be 1/4 times our period, which is 1 over 4 times 2 pi over 3, which is equal to what? Pi over 6. So that means each section on the x-axis is going to represent pi over 6. So we have pi over 6, 2 pi over 6, 3 pi over 6, 9 pi over 6. Do we have any reflections?
Yeah.
In which axis?
X.
So we have a reflection in the x-axis, okay? And do we have a horizontal translation?
Yeah. Pi over 3 units to the right.
So we have a translation of pi over 3 units to the right. Okay. So now we can start plotting, but we need to figure out the important points in a cosine function. So what are the key points we're looking at in a cosine function? So what is our cos at 0? 1. Cos at pi over 2? Cos at pi? -1. 3 pi over 2? 0. And 2 pi? 1. So now we're going to do what we did in the first question. We are going to use our mapping notation to get the new points of the graph. So we have x, y turns into, and what do our mapping equations look like? So 1 over 3x plus pi over 3, comma, and what would our y's be? -y plus 1. Okay. So our first point is going to be 0 and 1. And what would our new transformed point be?
Pi over 3, 0.
Pi over 3 and 0. Okay, so that would be, where would that be located at? So remember, this is pi over 6. The next one is 2 pi over 6. And what does that simplify into?
Pi over 3.
Pi over 3. So it'd be pi over 3 and 0. Our next one is pi over 2 and -1. No, pi over 2 and 0, sorry. And what does that transformed point look like? So you would have pi over 6 plus pi over 3.
Yeah. That's 3 pi over 6. Pi over 3.
You said 3 pi over 6?
Yeah.
It's going to be 3 pi over 6.
So pi over 2.
Yep, so pi over 2. And we have 3 pi over 6 is here. And what is our y value?
1.
1. And then we keep going. So we have pi and -1. And what would that transform into? 2 pi over 3 and 2. And where does 2 pi over 3 land in our x-axis? Mhm. And the next one we have is 3 pi over 2 and 0, which gives us what new coordinates?
5, 5 over 6, and 1.
Okay. And the last one, what can we assume the last one is going to be then?
Pi, 0.
Pi and 0. Once you get the first like 3 transform points, you can start seeing the pattern, and then you can probably just fill in the blanks just based off the maxes and the mins. So that is what our cosine function would look like. And does it make sense that it's reflected in the x-axis?
Yes.
Why?
Because there's a negative.
Yeah, because remember cosine usually starts at the maximum, and because it starts at the minimum this time, that is why the reflection in the x-axis makes sense for this graph. How do you guys feel about using radians to map out these new points? Is it more annoying than the regular polynomial functions, or is it just about the same?
Just gotta know the ones.
Once you have your critical interval, it should be pretty much smooth sailing after that. And just know the basic points of a cosine and sine function. I have to teach this course again in night school in January.
Night school? What time is that?
It's all online.
Yeah.
I just have to go into the building and teach from there.
It's the same. Oh, well, what time is like night school?
6:30 to 9.
Mine was 5:30 to 9.
Well, you did it.
But I did English.
Well, they made it longer this year because it's online. That's 3 hours of my life. That's okay. We'll just use what I recorded here. It's fine. So yeah. So the next one is going to be the trickiest one, only because the reflections are bigger. And what do we have to do in the bracket first? We're going to have to factor, okay? So we get y is equal to 2 times sine of 1 over 2x. The x should be in the bracket. X, and what would be left over?
X plus 1 over 2.
Or plus pi over 2. And then there's no vertical reflection up or vertical translation up or down. So what would our equation of the axis be, or c value? 0. So we have our equation of the axis on 0. What is our amplitude? 2. Is that what you wanted to see, Joseph? Which means, what would our max value be? 2, and what would our minimum be? Min is equal to -2. Okay, and now we want to find our period. But before I find our period, do we have a horizontal translation?
Yes. 5/2 to the left.
Yep. And now we want to find our period, which is 2 pi over k. So our k is 1 over 2. What would our period be? What's 2 pi divided by 1 over 2? 4 pi. So our period is going to be 4 pi. And if we want to figure out what we need to divide our intervals by, what are we going to do?
1 over, multiply by 1 over 4.
Yep. So 1 over 4 times the period, which is equal to 1 over 4 times 4 pi. And what would our critical interval be? Pi. So I'm going to make every other one pi, just so it's not all squished together. So this is pi, 2 pi, 3 pi, and 4 pi. Okay, so we know what a sine graph looks like because we already plotted it out. So now we're just going to use our mapping notation. So what would our x equations look like? Or the x coordinate equation? What would it be?
2x plus, no, yeah,
Minus
minus 5 over 4.
over 2.
Oh,
Right?
yeah,
Because we factored it
yeah.
out. That's the mistake I made when I was doing this the first time. I took pi over 4 by accident. And what would our y transformations be?
2y.
2y. So now, with that said, it's pretty much easy. So for our sine graph, our first point is going to be 0, 0. And what would our first transformed point be for the new equation? Negative pi over 2 and 0. So if this is this is going to be negative pi over here. So negative pi over 2 and 0 would be in between 0 and negative pi. So that is going to be our first point. What is our next point in a sine function?
Pi over 2 and 1.
And what does that transform into? So 2x times pi is 2 pi over 2 minus pi over 2, which is just
0.
2 pi over 2 divided minus pi over 2. What's 2 minus 1?
Pi over 2.
Yep. So it's going to be positive pi over 2. And what would our y value be?
2.
2. So let's go 2 here, negative 2. So pi over 2 and 2. Our next one is going to be pi and 0. And what would our new point be?
3 pi over 2.
And what is our value? 0. So 3 pi over 2 is going to be just between pi and 2 pi. So now just based off the general pattern, what would our next value, the next point be? And? Yep, and then after that?
7 over 2 pi and 0.
Mhm. So you can also see the pattern in the x values itself, okay? What was our critical interval? Pi, right?
Yeah.
So what's the difference between pi over 2 and 3 pi over 2?
2 pi.
2 pi over 2,
Oh,
which is
pi.
pi. Okay, so each one of these has a difference of pi, okay? And our critical interval was pi. So was that pretty, I guess, I don't know. For some of you, it might be easy. Some of you still probably need practice. So was it like okay, like easy enough to understand for now? Okay. So this is what the transformations of trig functions would look like. Next is just the exact same thing with just word problems. That's our next lesson. Okay. I'll probably do one example before the break for the next lesson, and then I'll do the other one after, and then we'll do the Kahoot. And then you guys will have time to work on your homework, and then I'll start marking your assignments.
What's the assignment on the 3?
So this is going to be the last mark before your
6
your term.
and 4. Unfortunately, they're all on that. I wish.